All right, so let's, yes. Yeah. They'll be available today. Yep. Right, so let's talk about imitating models, meaning mocking models, right? So basically, we've already seen that we can replace the input and the output. We've extracted the model into an interface, right? A particular implementation of that interface. Same thing with the controller, right? We've all made them implement a particular interface, right? With the intent, always with the intent that we should be able to replace them, right? So that when we're going to test them, right, we could test that we can replace it with something that we can control from the outside, right? That we've implemented our own streams, we've implemented our own controllers, and so we want to do the same thing with models. In particular, we'd like to see if there's any limitations with the current test harness that we have so far, and we'll see that there are indeed some weird things that the controller and our test might not be aware of what might be happening inside the controller, right? We're assuming that the controller is everything doing what it needs. We've only been focusing on testing the model. Yes, we've only been testing that we have this arithmetic, we have that algorithm that we pass you 2 and we pass you 3 and you come back with 5. I know we can test that, but there's an in-between there that, well, what about the controller? We haven't tested the controller. Is the controller doing what it's supposed to do? Right? Is the controller taking the inputs correctly and passing them along to the model? Could the controller do something in between, but between it reads it and then passes it to the model? Could there be something wrong in between there? Now, oftentimes, there could be something wrong, right? Because oftentimes the way the model represents the data and the way the view represents the data oftentimes are not equivalent, right? The model might be very hierarchical. They might have a lot of references from objects to other objects that build an entire data set. Whereas on the view, it might be very flat, right? It might be just an array of objects, and that's it, right? With very little hierarchy. Usually, the view always represents some very small snapshot, of the actual data set. You might have thousands of records in the data model, yes, of which you only consume 10 at a time, right? And then you have pagination, you have filtering, you have all sorts of things. The view is always a very crude subset of the actual model, yes, right? And so oftentimes there's a lot of manipulation, there's a lot of conversion and transformation between these two worlds, right? From the very detailed hierarchical data set in the model, right, to this very flat, crude subset representation in the view. Make sense? And the conversion between the two, the one who's responsible for doing this conversion, oftentimes is the model, the controller, right? That flattens the model so that it can be consumed by the view, right? Does some transformations enough for the view to render it. Yes? So is that working right? Should we test that conversion is happening correctly? Of course, right? We need to be able to test that, validate that, right? Is that communication working correctly? We know that we can test the algorithm, yes, but the algorithm works only if it gets the right data, right? And it spits out the right. So we need to test that too. Right? So some of the test limitations that we might have is that we need to be able to confirm that the controller is also doing the correct things, right? In its responsibility of playing the role of shuffling data back and forth between the view and the model, right? Something might have gone awry, right? Maybe, for instance, it could have inadvertently. It has 2 numbers, right? Number 1 and number 2, and presumably it needs to pass them to the model in a very specific order. It's number 1 and then number 2. I could have inadvertently swapped them, yes? Now, in an addition, it doesn't really matter. But if this were a division, then yes, it does matter, right? So did I, by mistake, pass the arguments in the wrong order? Right? It could happen, right? Or somebody down the line, somebody might introduce this bug, right? So we need to verify that the controller is indeed doing it correctly, right? Also, it could have been that inadvertently in my transformation, I inadvertently added something, or I subtract it from the value, or I divide it, or maybe I rounded it off, or I did something to the data after having read it correctly, but before passing it to the model, I did something wrong with it. And these obviously in our trivial example of just adding, we're looking for a problem to solve. It's kind of pulled out of our head. Probably not going to happen, but again, it's a very trivial example. But certainly, if this were a much more complicated, complex problem, we could, if this were matrices, are we inadvertently swapping rows with columns, right? If I'm iterating over something, did I mistakenly forget that this is 0-based as opposed to 1-based? Yeah, these things happen all the time, right? So we need to verify these transformations, right? So let's take a look at that. For instance, the test that we have so far, you say, well, I'm passing you 3 and 4, and the output is 7. Yes? Our test can verify that if I pass you a sequence of numbers 3 and 4, the output is 7. And it looks like it's doing everything we could possibly test. But let's look at this other controller, this bad controller, and it is inadvertently manipulating the two numbers. To number 1, it's adding 10. And to number 2 is subtracting 10. Right? Why would we ever do that? Well, obviously, yes, this is a mistake. Somebody added this somehow. In our trivial example, it's a contrived example. But nevertheless, if you notice that we are erroneously doing something to number 1 and erroneously doing something to number 2, because it's the add operation, the result is always it's still going to be the same, right? It's going to be correct. The result of this is going to be correct, even though, right, something happened in between that mismanipulated or mistransformed our number 1 and number 2. So our test would not catch that there's nothing wrong with this controller. It would say, yep, I'm passing 3 and 4, and I'm getting 7. There's nothing wrong with the controller. When there actually is, there's something wrong with the controller. Yes, right. So we need to be able to look into the controller, and somehow validate that there is indeed something wrong with the controller. Make sense? Right. We're going to see if that communication. So not only do we have the communication of the controller talking to the model, right? We also have the communication of the controller talking to the human being. Right? And we need to be able to make sure that the controller is talking correctly to both. Right? Up to this point, we have validated that we pass the correct values to the model, it spits out the correct thing, but we haven't validated that the inputs are being munched up, right? Yeah. Okay. So here it is, right? So we had mentioned earlier that the model, the specific implementation of the model that we were looking at. Was implementing an interface, right, which we never used, right? Somebody was pointing out that it was using an interface, and because it's using an interface, we could look at a different implementation of that same model. Yes, right? So we're going to indeed implement a different calculator model to see, how could we catch. Is there an implementation that we can verify that the input did make it correctly to the model, right? And it could not, and whatever output comes back from the model, right? We could detect that somehow the input got erroneously manipulated, all right? So let's see this other implementation of the model again, with the intent of trying to catch this bad controller, right? Bad controller. Right, so let's look at this other implementation for a model, right? So let's look at add. Again, we know that if we got the right answer, the right inputs and output, we know our algorithm is correct. So let's skip that part, right? Notice that this particular implementation of add always returns 0. Right? So I don't really care about testing the algorithm. I know the algorithm is okay. We're trying to explore the idea, could we, from within the model and the implementation somehow catch the fact that somehow the inputs that are coming, it's not really what you should expect, right? if you come in with 3 and 4, can I return something that is going to compare my expected value with my actual value and say, wait a minute, no, I passed 3 and 4, and you're coming back with 13 and minus 6. Right? Well, what happened in between? Somehow the controller did something bad. Between me passing you the data and you coming back with something bad. Make sense? Right? So what we're going to do is that we're going to also pass along in our model a log that it's going to capture the evolving data that is passing along. For instance, here's num1 and num2, and we're just going to concatenate those two values, num1, and we're going to concatenate it with num2, and spit out the actual values that we got. Right? I got a 3, I got a 4, right? And this string is going to be different if you instead pass me number 1 plus 10 or number 2 minus 10. Yes? Right? If this were just a normal implementation, I would not have caught it. You pass me 3 and 4, or you pass me 13 and minus 6, it still adds to the same thing. Yes? But this string concatenation, there's no way that I could miss that this was supposed to be a 3 and 4. Instead, I got a 13 and a minus 6. Yes? All right? And when I compare, it says, wait a minute, I did pass you a 3 and a 4, but why are you coming back with a 13 and a minus 6? All right? So this add, now if we write the test in terms of this new model, here we have that we're still passing the string reader of 3 and 4. Notice that the output, we don't really care about the output, right? That's why the builder is don't care output. We know it's going to come back as 0, right? We know it's going to come back as 0 always. Instead, right, we're going to pass a string builder log where it's going to write, the output that it's coming back from that add, right? And that add is concatenating the values that you pass me. Right? And in the BadController, it's I'm not going to get the 3 and I'm not going to get the 4. Instead, I'm going to get a plus 13, right, and a minus 6, right? Because I've added 10 and I subtracted 10 in my BadController, this would fail, right? This test would fail and would catch that BadController. That make sense, right? So the idea is that can we rewrite our models? Can we rewrite our controllers, right, in such a way that we can catch not only the algorithm that is calculating this correctly, but also any communication from the user all the way down to the model. Right? So that was the right. This particular test, or this particular implementation of the model allows us to distinguish this BadController from all the other ones that were doing this correctly, right? And the reason, right, is that we have to make sure that all communications are tested, right? We need to identify that the control not only is the controller talking to the model, right, but it's also talking to the user, and so both of them need to be tested, right, independently, which we already had tested the algorithm, but we need to also test the data that goes down up to the down to the model. Okay, that there's two directions for the controller to test.